Hello friends, welcome to the online lecture series of Basics of Computer Network. Myself, Assistant Professor Mr. V.R. Vadekar from Department of Electronics and Telecommunication from Matoshi College of Engineering and Research Center, Nasik. Guys, today we are going to start a second unit, that is error detection, correction and data link control. So let's start with the content of unit number 2. Students, in this unit, basically we are going to study data link layer services, framing, error detection, error correction, flow control, error control, then what is linear block codes, then Hamming distance, what are cyclic codes, what is CRC, that is cyclic redundancy check, what are the different advantages of cyclic codes, why we are going to use these codes, then other cyclic codes like your checksum, internet checksum. Then after that, we are going to study about a framing, that is fixed size framing, variable size framings. Then we are going to study about the flow control, that is what are the different flow control protocols, what is noisy channel, what is noiseless channels, and what are the different protocols it comes under that one. And after that one, we are going to study of noisy channels, that is your stop and wait ARQ, go back ARQ, selective repeat ARQ, what is piggyback. And students, the reference book that we are referring is of BA Forozen, that is data communication and networking. And by covering this unit, basically guys, we are going to satisfy the second outcome, that is analyze data link layer services, framing, flow control, error detection and correction, and linear block codes and cyclic codes. Now guys, what are the objectives of this unit? Why we have introduced this subject is this unit in your syllabus? So in order to understand what are different data link services are there, to understand what is error correction, error detection it is there, then to understand linear block codes, what is framing, flow control protocols. And after completing this unit, students would be able to understand what are linear block codes like your Hamming codes, cyclic codes, understand framing, what are its types. Then they would understand what is noiseless, what are noiseless channel protocols, what is noisy channel protocols, and so on. In today's module, we are going to study about data link control services. And the first services it is of framing. And then we are going to discuss flow control and error control. So guys, let's start with data link layer. Now, this data link layer is responsible for moving frames from one hop to the next. And basically, this layer, which is, it is placed between network layer and physical layer. So it makes your physical layer to a reliable link. So as shown on the screen, this is the position of your data link layer. As we know that data link, it adds header and this trailer to the packets coming from your network layer. And this encapsulated data, we call it as a frame. Now, what are the different services that data link layer it gives? First is framing, flow control, and error control. So we are going to study one by one. So guys, let's start with framing. Now, The data link layer, it needs to pack bits into frames so that each frame, it is distinguishable from one another. And our, as like your, our postal system, it practices same type of framing. It is a simple act of, inserting a letter into an envelope, which is going to separate one piece of information from another. And this envelope, it serves as the delimiter. And then what are the types of frame? It means frame size. That is a fixed size framing and variable size framing. So fixed size framing means, now in fixed size framing, there is a no need for defining the boundaries of the frames because the size itself, it can be used as a delimiter. Next, it is your variable size framing. As the name suggests, there is a need to define the end of one frame and the beginning of next frame. So guys, basically two approaches were used for this purpose. First is, it is your character oriented approach, and second, it is your a bit oriented approach. Now first we would start with this character oriented approach. Now in this approach, you can see on the figures guys, that is data to be carried are 8-bit characters, from a coding system such as your ASCII, and the header, which normally, it carries the source and the destination addresses and other control informations. Talking about this trailer, basically trailer, it carries error detection redundant bits, which are also, multiples of your 8 bits. And talking about this flag, which shown in this yellow color, basically to separate one frame from the next, an 8-bit flag, it is added at the beginning as well as at the end of the frame. So basically it composed of protocol dependent, special characters, which is going to signal the start or end of the frame. Now, a character oriented framing, it was very popular when only text was exchanged by the data link layers. So, the flag, it could be selected to any characters or, that is not used for the text communication. But now guys, however, if we send other types of informations, such as your graphs, audios, videos, so any character, used for this flag, it could also be a part of the information because usually our information, it is not just a text. It consists of, this mixture of your audio, videos and graphs. So whatever the character, if you are going to use for the flag, it may happen that it could also be a part of your information. So if this happens guys, the receiver, when it encounters this pattern in the middle of this data, then it thinks it has reached the end of the frame. Because as we know, flag, it is going to indicate, it is going to signal the start and end of the frame. So in between, the data pattern, if the flag it occurred, then the receiver may think it has reached the end of the frame. Now, to fix this problem, guys, a byte stuffing strategy, it was added to this character oriented framing. So we are going to add this to the data section of the frame when there is a character with the same pattern as the flags. Now, the data section, it is stuffed within this extra byte, and this byte is usually called the escape character, and it has a predefined bit pattern. So whenever the receiver it encounters the escape character, it removes it from the data section, and it reads the next character as a data, not a delimiting flag. So you would get the more clear picture by this figure. So if you will observe this, the data which is coming from the upper layer, you can see that flag itself, it is a part of your data, right? So what we have done, guys, so basically you will observe on the screen, if the flag it has been coming itself as a part of the data, then we are going to insert a escape character which is called a byte stuffing, so that at the receiver, guys, whenever the receiver it is going to encounter this escape character, then it is going to treat this flag portion as a data, not as it is think it would the end of the frame, because the escape character it is previous this flag. So when we are going to receiver it is going to encounter this escape, it would automatically understand that the next part of the data, that is your flag, it is not going to indicate the end of the data, it is just a part of the data. So guys, this is byte stuffing. But another problem it may arise, guys. What is that another problem? The escape character that we are going to use it over here, that I'm going to show it on the screen, it may happen as like this flag it became the part of the data, there may be a chances that escape character it would be a part of the data. It may happen. So for that, how we are going to fix this problem? Then we are going to add again escape character. See, this escape character, it is taken as your data, and preceding to this escape, which is your actual data, again we are going to stuffing this escape character. So when the receiver it is going to encounter this escape character, then it would come to know whether the next portion it is a flag or itself it is an escape character. Then it is going to take it as a part of the data. That is called unstuffing. Over here we are going to do it byte stuffing. It means we are inserting escape character, whereas at the receiver we are going to extract these escape characters, which is called what? Unstuffing. So hope so, guys, you understood about what? Byte stuffing. That is flow, that what we are going to do it over here, it is in character oriented approach, that escape character it is a part of the text, then extra one is added, that I shown to show that second one it is a part of the text. Okay, now, so byte stuffing, it is a process of adding one extra byte whenever there is a flag or escape character in the text. Now moving towards a bit oriented protocol. So guys, in bit oriented framing, what is going to be happen? The data section, see, this is your data section. So the data section of a frame, it is a sequence of bits that to be interpreted by the upper layer as a, it could be as a text, audio, video, or so on. Now, in addition to this header and to this trailer, we still need a delimiter, to start, to separate one frame from the another. So most protocol, it uses this 8-bit pattern, that is 0 11110. It is nothing but your flag as a delimiter. To define what? To define the beginning and to define the end of the frame. So we are going to insert this flag at the beginning as well as at the end of this frame so that it would act as your delimiter. Now, as this problem, that we discussed in your previous scenario in character oriented protocol. So this flag, it can create the same type of problem that we saw it earlier. So suppose if this flag, this bit pattern, if it appears in this data portion, then we need to somehow inform the receiver that this is not the end of the frame, because it may happen same bit pattern it would occur during this this data section. It would come into the data section and then receiver would come to know that it is the end of this frame. So although it is not, so we need to inform this to the receiver. So for this purpose, guys, what we are going to do it, we are going to use a bit stuffing. So bit stuffing, it is a process of adding one extra zero whenever 5 consecutive ones, follow 0 in the data, so that the receiver doesn't mistake the pattern 0111110 for a flag. So you would come to know about this one, you would get the clear idea. So what it tells, that if flag, it is consecutive, what is going to tell? The consecutive 6 ones are there. So bit stuffing, it is the process of adding extra 0. Extra 0 if consecutive 5 consecutive 1 bits are encountered. It means, suppose, just wait a minute. Suppose 0 it is there, then consecutive 5 ones are there, 3, 4 up to 5 this one. So after this one we are going to insert 0 over here. So this is nothing but your bit stuffing. So now see this figure, you would get the clear idea about this one. So you can see this pattern over here. The flag light pattern, see the 0, 111, 111. So what it tells, if a 0 it is there and a 5 consecutive ones are there, see over here, 0 and this 5 consecutive ones are there, we are going to add this extra 0. We are going to stuff it. This is called a bit stuffing. And similarly, guys, over here also you can observe it, that 0 and 5 consecutive ones are there. Then again we are going to add one extra 0 to it, which is called a bit stuffing. And this extra bits, extra 2 bits, eventually it is removed from this data by the receiver when it has been reached to the receiver. So whenever the receiver it is going to face that 0 and 5 consecutive ones are there, so regardless the value of the next bit, it is going to take the next bit as a data, not, it is going to considering the end of the frame. Similarly over here, we are going to remove this one. So 0 and 5 consecutive ones are there. Then receiver knows that while unstuffing, I need to, extract the 0 and take the next bits as a data. So which is called what? Unstuffing. So hope so you understand about a character oriented and bit oriented approach. Now, the most important responsibilities of the data link layer are flow control and error control, guys. And collectively, these functions are known as what? Data link control. Now, first of all, we would start with the flow control. What is flow control? Flow control, it refers to a set of procedures which is used to restrict the amount of data that the sender can send before waiting for the acknowledgement. Suppose, guys, any station it is going to, any sender it is going to send the data at a rate of 10 Mbps. But the receiver, it has a capability of receiving the data of 5 Mbps only. So what is going to be happen? The receiver would be overwhelmed. Either it needs to what? Discard those packets, or it would stop. So flow control, it is a procedure that it makes a balance between the transmission rate and the reception rate, so that the data that we have transmitted, it should not be lost, and the receiver that it is going to receive the data, all those data, it should be delivered to the upper layer. So whenever an entity, it is to produce items, or you can say it as a data, another entity, consumes them. So there should be a balance between the production and the consumption rates, as I already told. So if the items are produced faster than they can be consumed, then the consumer can be what? Overwhelmed. And it then there may be chances of discarding those items. And suppose if the items are produced more slowly than they consumed, then definitely the consumer, it must wait, and the system becomes less efficient, because receiver has the capability to absorb the data, while the sender, it doesn't have that, that capability to send the data as much the fast as it requires. So due to which bandwidth it is going to get, waste. So it is going to be less efficient. So in this figure, you can see it, that how the sending nodes, it is tries to, you know, push frames towards the data link layer at the receiver. Frames, it has been pushed. And if the receiving node, it can't process and deliver the packet to its network layer at the same time, at the same rate that the frame arrives, then it becomes what? Overwhelmed with frames. So flow control in this case can be a, it feedback. This, see the feedback, it has been shown from the receiving node to the sending node to stop or slow down this pushing of the frames. So how we are going to implement, guys? So flow control, it can be implemented in several ways. But one of the solution is normally to use what? Two buffers. One at the sending data link layer and other at the receiving data link layer. And what is buffer? It is nothing but a set of memory locations that can hold the packets at the sender and the receiver. And then this flow control communication can occur by sending signals from the consumer to the producer. And when the buffer of this receiving data link layer is full, it informs the the sending data link layer to stop pushing frames. Now, talking about, guys, error control. What is error control? So basically, error control, in the data link layer, it is based on automatic repeat request. It means what? It is a retransmission of the data. Now, guys, this, the underlying technology, that is at the physical layer, it is not fully reliable. We need to implement error control at the data link layer. to prevent the receiving node from delivering what? Corrupted packets to its network layer. And error control, at the data link layer, it is a quite simple and implemented using one of the following two methods. In the first method, if the frame, it is corrupted, if the frame is what? Corrupted, then it is silently discarded. And if it is not corrupted, then the packet it is delivered to the network layer. And this method is used mostly in wired LAN, such as what? Your Ethernet. This is the first method. Whereas in second method, if the frame, it is corrupted, then it is silently discarded. See, but if it is not corrupted, then an acknowledgement is sent to the sender, which is serves as a both, purpose of both flow as well as error control. In first method, there is no acknowledgement. We are not waiting for acknowledgement. Whereas in second method, we are waiting for the acknowledgement. And one more thing, guys. A combination, basically we are going to combine this flow control and error control. In simple situation, the acknowledgement, that is sent for this flow control, it can also be used for the error control also, to tell the sender that the packet has arrived uncorrupted. Whereas the lack of acknowledgement, if we are not going to send the acknowledgement, then there may be a problem, in the send frame. So a frame, that carries an acknowledgement, it is normally called as ACK. Acknowledgement frame, that is we are going to study in next lecture to distinguish it from the data frame. And just for a discussion, a DLC protocol, it can be either. Now this in connection oriented, there is a logical connection. It should be first established between the two nodes. That is, setup phase. And after all the frames that are somehow related to each other are transmitted, that is called a transfer phase. After the transfer phase, the logical connection is terminated, tear down phase. Whereas in connectionless protocol, frames are sent from one node to the next without any relationship between the frames. Each frame, it is a independent. As like in connection oriented, you can take the example that if family members, 5 family members are there in a family, then they want to go for a journey, then what they are going to do it, they are going to go buy a car, or they are going to buy their own car, or they are going to take a rent. Then a route it is fixed from their source to the destination. That is called a connection oriented, because all the 5 members of a family, they are going to traveling by the same car and through a fixed route. That is called connection oriented. Connectionless, you can see that those 5 members of that family, they want to reach to the same destination, but they are going to follow a different routes. Some is going to go by someone is going to go by bus, someone it is taking car, someone by aeroplane, as like that one. So there is no relationship between those members. They are independent of each other. So it's all about, guys, today's lecture. So we have started with this second unit, and we came to know about this data link control services, that is framing, what is bit oriented approach, character oriented approach, why we do this byte stuffing, bit stuffing, the problems associated with that one. After that, we discuss about flow control. What is flow control? Then error control. Here it is the assignment that you need to solve it. So please note down this assignment. In next video, we are going to discuss about the types of the protocols. And then one of its type, that is a noiseless protocol, that we are going to discuss it. Here it is my email address shown on the screen. So thank you very much, students, for today's lecture.